Okay, so now I'm going to go back to nib. So if I'm going to use math, I have to somehow describe what you're seeing or playing using mathematical notation. So I'm going to define xn to be the state of the first player when there's n tokens. So xn's either in a winning state or a losing state. So the values xn can take on are what? 1 or 0. So xn equals 1 means player 1 can win with that number of tokens, and xn equals 0 means player 1 will lose with n tokens, just like we did before. And you're going to have an in-class assignment on this, so I would take notes so that you have the notes in front of you. You don't really need this slide, but I think starting the next slide, you'll need the makeup of what's going on next. I'm going to start with the first baby game that we played with 1-2. Remember 1-2? That was the easiest subtraction set. Tokens. I'm just going to label the tokens above 1, 2, 3, 4, so forth, so you can see the position that you're in. And recall that this was the sequence that you all came up with that first day when you played NIM and you used backward induction. Remember that? And x3 was, and then well, I want to know, why was x3 0? Well, x3 was 0 because x2 and x1 are, x2 and x1 are 1, not 0. Or x2 times x1 is 1, right? That's another way of saying both of them had to be 1 at the same time. The only way you can lose is if you move back in the subtraction set and all of them were winning positions. Another way to say that is if I multiply those things, they ended up being 1. Right? If all of them are 1, then the product is 1 too. x4 is 1 on the other hand because x3 is 0 didn't matter. It didn't matter that x2 was 1. It only mattered that I could move this into a losing position, right? I could remove one token and they're in a losing position. So only one of the move backs had to end up being 0. Once I know that one of the move backs ends up being 0, I know I can sprawl my other opponent into a losing position. And that's the reason x4 is 1. Or another way to say that is the product of x2 and x3 was 0. I just need one of them to be 0 to be a winning, right? You agree? So if one of them is 0, then the product's 0. Is it making sense? If you're as tired as me, nothing makes sense. So you're lying. Mod 2. Everything we do here is mod 2, that addition table. 1 plus 1 is 0. We're working on Z2. No more real numbers anymore. In fact, that's what we should get as a t-shirt that says no more real numbers, an R with a slash through it. Z2 is better. Is it true in general? Can I write, is that the recursion? The xn is xn minus 1 times xn minus 2 plus 1 mod 2? Because then I've got a recursion formula, and that's pretty cool. So notice I saw a pattern here, right? That x3 was x2 times x1, x4 was x3 times x2 plus 1. Is that true in general? So what I'd like you to do in in-class assignment is to compute x5, x6, x7 using that recursion formula that I just gave you. And then compare it to the pattern that we found Thursday. Does it end up actually being 1, 1, 0, 1, 1, 0, 1, 1, 0? Check. And again, you only need to turn 1 per group with both of your names on it. So you need to watch whoever's turning it in because sometimes they don't put the other person's name on it. I saw you giving her a look. Try it. Catherine. You should do the open comments in here. You see the light screen. So Tyler.
Okay, so.
Melissa and Amanda. Stephanie. So Sana didn't turn in her version to me. There was one question on the end that wasn't. So if you have it on your version,
So isn't this the same thing?
then you can just put that it's on that Stephanie's, you guys work together. So I thought maybe you just missed it because everything else was really careful.